Hello everyone, this is Dino Chris from Prehistoric Facts. This would be an extra episode, and I chose a topic in geology, paleontology, all kinds of forms of geology, and that subject is the geologic time scale. So this is the most updated version of the geologic time scale from the Geological Society of America, and I'll give you a little more details about this timetable and near the end of the video, but let's actually get right towards this episode, shall we? Why is the geologic time scale so important? Well, first of all, it's used in all geology subjects like paleontology, structural geology, geochemistry, geophysics. I mean, all the forms of geology. And paleontology is part of geology, just so you know. And it is also helpful for the fossil record because, first of all, you need to know what kind of fossils are found in all these types of eras, periods, epochs, ages, all those sorts of things. And so that's why we can actually give those eras some names and these periods some names. But also, it's also helpful for the magnetic field, believe it or not. In the geologic time scale, there is a section when you have the Mesozoic and the Cenozoic, you see the magnetic field portion where you actually, it looks like almost like zebra stripes in a way. And I'll show you in a little bit at the end of the video. It also tells how old the Earth is, the age of the Earth. And so we'll actually go through the eras today. I'm not going to go through the periods. That is just a little bit too much to do for one video. So I would think, like, if you want me to do one on certain periods, I can do that. And so just let me know ahead of time. And it also kind of actually helps for the rock formations, because with the ages of the in the geologic time scale, it's basically about what kind of rock formations are found around the world, basically, and that's how you actually know how old certain rocks are. But they use radioactive dating to actually do that, and they do that with not only just igneous, they do that with igneous rocks, volcanic rocks. The sedimentary rocks are very soft rocks, like your limestones, sandstones, and your shales, and also your siltstone. And also for the metamorphic rocks, too, because you need to know how old those rocks are. And so we'll start with the Precambrian era. And so the Precambrian era pretty much starts 4.6 billion years ago, and that's pretty much when Earth actually started. Earth is 4.6 billion years old, and so I'm only going to show pictures most of the time in these slides, so you're not going to get too much of words actually showing up here. But anywho, when the Earth actually started, it was actually kind of very volcanic. So this picture in the upper right corner, you can actually see here is a bunch of volcanoes, and so that's what Earth looked like back then. There was no oxygen. There was not too much of an atmosphere yet, and so this is why the volcanoes were there, to actually build up an atmosphere. And on the bottom left corner, around 2.6 billion years ago is when oxygen was actually being released into the atmosphere. And there is a rock formation that you can find. It is called the Banded Iron Formation, or BIF. And that is a clue of when Earth started to actually have oxygen in its atmosphere. And so when you actually see like those orange colors in the Banded Iron Formation, that is because it was rusting. And how does iron rust? Oxygen. And so that's how you actually get that. And then there was another kind of thing that actually happened in the Precambrian, and that was Snowball Earth. Snowball Earth actually happened 650 million years ago. So on the bottom right corner, you actually see Earth was actually covered with glaciers or ice 650 million years ago, and that is amazing to think. We thought that the most recent ice age was actually the ice age. That was the ultimate ice age where Earth was covered with ice. And so there are certain peaks of water showing up and certain parts of land were showing up, but you're not going to find a lot there. But in terms of forms of life in the Precambrian, the first bacteria actually started showing up about 3.4 billion years ago. And so they actually probably, kind of like what you see in the thermo sectors of the Earth are, where you actually see like really hot volcanic areas in the oceans, and you see all these forms of life starting to show up there. And bacteria were actually single-celled organisms back then in the Precambrian, back 3.4 billion years ago. There wasn't any multi-cell bacteria yet. That would probably go towards 1 billion years ago. And then or otherwise I would say around pretty close to 2 billion years ago is when like you start to see the first colonies of bacteria start showing up. But the other kinds of life that actually started showing up were before the Cambrian period, before the Paleozoic era. Yet in this upper left corner picture here, this is way before. This is a little bit before the Cambrian era, or the Cambrian period, Cambrian period. And this is what life would have actually looked like. Very unusual, almost alien-like. And so you got like these, almost like these sea plants and these first invertebrate animals. And so these are animals here. These were not actually just forms of bacteria. But some of these would actually ultimately start to become some of the first vertebrates, the invertebrates, all that sorts of stuff. But now we get to the next era, the Paleozoic. The Paleozoic is pretty much where life actually, the first actual forms of life actually began, where we actually start to see like some of the first land animals, some of the first more complex life forms on Earth at that particular time. So the Paleozoic is 540 to 252 million years, and so long period. Cambrian is actually 4.6 billion years to 541 million years. So anywho, but Paleozoic. So the Paleozoic actually begins with the Cambrian, and this is where you see the Cambrian explosion. And the Cambrian explosion is where life pretty much just exploded, with like all these types of life forms started to come about. The first arthropods, the first invertebrates, some of the animals that ultimately will become the first vertebrates, all that sorts of stuff. And all that kind of stuff, all these fossils that are seen right here in the upper left corner, that is from the Burgess Shale. That is a very famous rock formation, mostly found in Canada. And if you actually do go up to the Burgess Shale at some point, like either in Canada or someplace else, wherever you find the Burgess Shale, it is spectacular. You actually see all these different kinds of life forms, trilobites, the first super predator, Anomalocaris, all those sorts of animals. It is pretty magnificent. But then you actually have like some of the first vertebrates, the first fish. And the first fish are pretty much about the size of your thumbnail. Very, very small. Then how you can tell that they were the first fish is that they have a very primitive backbone. First vertebrae. And so they have like a spinal cord. So that is pretty cool. But the first fish, these first fish ultimately started to form the first jaws. Then they become the lobed fin fish. But it wasn't around the Devonian is where we actually start to see some of the lobed fin fish actually exit the water. And this middle right picture right here, that is Tiktaalik, a very key fossil that was actually found in Canada, where it is a fish that ultimately started to actually walk on land. And so it almost looked like an amphibian, but it's not like an amphibian. It is actually a little bit towards the fish family, the lobed-fin fish family, and it actually was able to walk on land, but only for a short period of time. And so it was the first lobed-fin fish to actually ultimately walk on land. And so that ultimately gave rise to the amphibians. And then the amphibians actually started to take over. Amphibians got huge around the Devonian age. But when you actually start getting into the Carboniferous era, or the Carboniferous period, excuse me, that oxygen levels were starting to rise significantly because of the first plant life. And so ultimately those plants started to become like the first ferns, some of the first trees, all that sorts of stuff. And arthropods got huge. They got huge. Like dragonflies, like ancestors of dragonflies that were actually about the size of an eagle. Millipede, centipede relatives that were as long as a car. I mean, scorpions that were 3 feet long. I mean, it is unbelievable. But also in the Carboniferous, you actually start to see the first reptiles. And so the first reptiles started out small. And then when it gets to the Permian, we actually start to see reptiles took on all different kinds of forms. So in this bottom left picture right here, you actually see is Dimetrodon. And Dimetrodon is pretty much the face of the Permian period. And so that's where you actually have some of the first mammal-like reptiles actually started to come around. And mammal-like reptiles almost look like mammals too. In the upper right corner, this is the Gorgonopsids right there. And so the Gorgonopsids almost look like your typical dog or cat but they were reptiles. And so they actually were kind of like the proto-mammals. But other kinds of reptiles actually came around then in the Paleozoic, and that actually ultimately became some of the archosaurs that actually thrived in the Triassic period in the Mesozoic, but those guys survived. But then that's when we actually get into the next era, the Mesozoic. The Mesozoic era. The Mesozoic era is 252 to 66 million years ago. This is the age of reptiles. And so reptiles pretty much took over the earth. Reptiles dominated not just on land, they dominated the ocean, and even they actually dominated the skies. And so Triassic period is where we start to see the first dinosaurs. In the upper left corner, that is Coelophysis. And so Coelophysis, one of the first dinosaurs in North America. And then pretty much the Triassic period is where dinosaurs were pretty small. Archosaurs were the top predators. So dinosaurs were pretty much a small snack for archosaurs. But then in the Jurassic period, dinosaurs got big. And that's where we start to see the first sauropods. And that is a picture right there of Diplodocus, or Diplodocus, however you want to call it. And so sauropods got pretty big. They were very common. And the first theropod and some of the big theropod dinosaurs actually start showing up in the Jurassic period. But in the Cretaceous period, that's where the sauropods were in decline. And you actually had your ceratopsians, your iguanodontids, hadrosaurs, and raptors. And so the bottom right corner, that is actually Velociraptor. It did have feathers, yes. So all you kids know, Velociraptor did have feathers, people. It did have feathers. And then on the bottom left, you have Tyrannosaurus rex, and the Tyrannosaurs were actually starting to become pretty dominant in the late Cretaceous period. And so Tyrannosaurus rex being the biggest of all the Tyrannosaurs. But the pterosaurs, the flying reptiles, they did get huge at the end of the Cretaceous period in the Mesozoic era. At the end of the Mesozoic era, we actually have pterosaurs that were as tall as giraffes and had a wingspan of 40 feet. That is incredible. And then after the Mesozoic era, we're in the era today, the Cenozoic. We're in the Cenozoic era. And it's still continuing on, 66 million years to today. And so the first true mammals, actually, the first types of mammals that we actually, or what we see to look like the modern day mammals, pretty much actually kind of started to evolve. Mammals didn't really actually start coming around until dinosaurs started to actually come on to basic dinosaurs pretty much coming in, pretty much be on land, or when dinosaurs first evolved, I should say. And dinosaurs first evolved around 230 million years ago. And so mammals probably actually started to evolve probably close to 200 million years. So they're pretty close. But the more famous prehistoric mammals, this upper picture right there, that is Smilodon, or the saber-toothed cat. And then on the bottom picture right there, that is the woolly mammoth. So your iconic prehistoric mammals of the Cenozoic era. But we also, our species actually started to come around in the Cenozoic. Our human ancestors actually pretty much started to evolve pretty close to 5 million years ago, and so that is pretty cool. And so that is awesome. And then we have 5 mass extinctions in the geologic time period. We have the End Ordovician, 445 million years ago. The Devonian, there was multiple extinction times in the Devonian. I'm not going to get through all of them. The End Permian, 252 million years ago. That is the biggest extinction of all. The End Triassic period, 201 million years ago. Then the End Cretaceous, or the KPG extinction, and that is the more famous extinction, and that is 66 million years ago. So all these pictures actually kind of show what was around in those types of particular times. Here's the Ordovician in the upper left corner, upper right corner, Devonian. In the middle right here, that would actually be what was the Permian extinction, the Siberian traps in Siberia, basically. Large volcanic eruption, pretty much killed off 90% of life on Earth. That is a big extinction. Triassic period, this is what was around in the Triassic period, bottom left corner. And then pretty much we all know what the End Cretaceous, or the KPG extinction is. And it was a giant asteroid that hit the Gulf of Mexico, causing numerous events. And back to this GSA, Geologic Timescale. If you do want this Geologic Timescale, you go to the GSA website. I'll put a link on the description, so that way you guys can actually print it off. You can just print it off, do via PDF, and that's how you're actually going to do it. And so you don't have to get the poster. You don't have to buy the poster. You can print it off yourself. And so you can. I'll leave you the link in the description so you guys can actually get it. So the next episode is on November 1st. Of 2018, and there'll be a special episode. I'll let you guys know what kind of prehistoric animal I'm going to talk about. So, but even though you could still send me questions about dinosaurs or any other prehistoric life by emailing me at dinochris71@gmail.com, or just go on my Facebook page, Prehistoric Facts with Dino Chris. Like the page, you guys should post your questions on the wall or in the Facebook or in the comment section. But remember, keep your questions short and to the point. Don't send me the same question over and over again, and don't send me multiple questions at once. Don't send me, like, say, 6 or 7 questions at once. Try to actually just send me 2 or 3, so that way I can read them all. Because if it's 6 or 7, that is all in one. I can't do them all. So keep it minimal. And then you can also follow me on Twitter at CSGRALL. That's my Twitter page. I post pretty cool stuff on there. Also, take care of the people around you, and also for younger people out there, to make sure you listen to your parents, your teachers, and your guardians. It's the best motivation you could have. A good education. It's very important to have a good education. With a good education, you get a good job in the future. That's it for now, and I'll see you guys next time.